Albert Einstein once wrote about his prediction that humanity would never be able to observe the boundaries of the universe. This notion seems to find validation in the recent observations made by the Webb telescope, which has detected a void in the early universe that might support Einstein's theory. But what exactly are we witnessing? Is it truly a void, and could it represent the origin of the universe? Scientists have unearthed a startling possibility. A peculiar void at the dawn of time might indeed confirm a significant prediction by Albert Einstein. Imagine the awe of scientists a century ago as they began to peer beyond the confines of the Milky Way. Initially, they observed hazy nebulas, but it soon became apparent that these were, in fact, other galaxies. First, the small and large Magellanic Clouds became visible, followed by the Andromeda Galaxy. Eventually, to their astonishment, scientists realized that countless galaxies existed beyond our own. These discoveries gave rise to concepts like the evolution of galaxies and the infinity of the universe. Then, Edwin Hubble noticed that distant galaxies were receding from us, leading to the idea of the universe's expansion. Shortly thereafter, Belgian scientist Georges Lemaitre proposed the Big Bang theory. This all transpired shortly after Einstein introduced his theories of relativity. Many theoretical predictions made in the 1910s and 1920s were later confirmed by these new findings. However, Einstein remained uncertain throughout his life about whether the universe truly had a beginning and an end, despite his fundamental acceptance of the Big Bang theory. Nonetheless, he was convinced of one intriguing notion. Even if the universe did have a beginning and an end, we would never be able to observe them, regardless of how advanced our telescopes became. So, how did Einstein conceive this seemingly outrageous idea, and what connection does it have with the void discovered by the James Webb telescope? Einstein was undoubtedly one of the most influential physicists of the 20th century, and his predictions still underpin much of modern science. One particularly profound insight was his prediction that we could never directly witness the absolute beginning of the universe. Einstein offered two compelling reasons for this. Firstly, according to the Big Bang theory and other related theories, there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists refer to this period as the Dark Ages. How could we observe a moment or event through telescopes when there was no light? Although there are intriguing answers today, such as the use of radio telescopes that listen rather than see, researchers are fairly certain that the Big Bang was not a noisy explosion but occurred in complete silence. The space in which an audible explosion could have occurred didn't even exist at the time of the Big Bang. Space itself was created by the Big Bang and expanded as a result of it. Radio telescopes detect waves far outside the audible sound spectrum, as space conducts sound poorly. Only a few other waves penetrate the interstellar medium and can be converted into audible sounds using modern technologies. Thus, we would not be able to truly hear the presumably silent origin of the universe. The discovery of cosmic background radiation in the 1960s, which has since been extensively mapped, is considered an aftereffect of the Big Bang, and much of the evidence supporting the Big Bang theory has been derived from it. However, the microwave background has never led us directly to the Big Bang, so it appears we have no way to detect or prove the absolute beginning or the Big Bang itself. Furthermore, Einstein believed for another reason that we could never see the absolute beginning or edge of the universe. He theorized that due to the universe's expansion, the beginning would recede further and further from us, placing it forever beyond our line of sight. Additionally, Einstein sometimes postulated a curvature of space, which means that the starting point could be hidden behind a kind of cosmic horizon, perpetually concealing it from our view. Imagine, once again, that this was an era when the most advanced telescopes could only offer blurry glimpses of neighboring galaxies. Today, we know of the existence of millions of galaxies in a universe teeming with them, expanding and growing ever larger. It might seem nearly impossible to see far, but this is not the case. Although our cosmos is vast, the distances between galaxies and galaxy clusters are so immense that we can now observe up to 13.6 billion years into the past with our telescopes, coming very close to the Big Bang. And with the James Webb Space Telescope, we are closer still. But the Webb telescope does not show us what scientists 100 years ago would have called the Big Bang. The JWST has discovered a strange void. You may have heard that the JWST has uncovered an extremely large number of very old galaxies, challenging the Big Bang theory. But did you know that it has also found a peculiar void that could confirm Einstein's prediction about the impossibility of observing the universe's absolute beginning? Absolute voids are mysterious regions of the universe that are so empty, they seem to contradict the theory of relativity. But how can they confirm Einstein's ideas about the invisibility of the beginning? Initially, this emptiness was thought to be indicative of the Dark Ages, when there were no stars or galaxies. Some researchers believe this discovery at least confirms the existence of that era. But then came the surprise. The darkness turned out to be an extremely distant void. We also know of closer and more recent voids, and even these pose significant puzzles. However, in the extremely early universe, voids present a scientific paradox. They don't fit into the concept of a homogeneous universe, which is closely tied to the idea of the Big Bang or the universe's expansion. Voids are too large and too strange. They possess an inhomogeneous nature, contradicting some of the fundamental principles of cosmology. A void does not necessarily confirm Einstein's prediction, but the Webb telescope seems to validate the brilliant scientist's view in another way. So far, the telescope has found no evidence of a beginning or an early stage of the universe. The images of the allegedly early universe only show structures and galaxies that don't look much different from those we can observe more closely. Could a void have marked the beginning of the universe? This raises the question of whether a mysterious void could indeed be the universe's origin. We cannot completely dismiss this idea because, ultimately, we do not fully understand what voids really are. And today, we must also admit that we do not know how the universe truly began. Voids are probably empty, but we cannot be certain. It's possible they contain some form of matter that we haven't yet identified, perhaps dark galaxies. Voids are sometimes interpreted as parallel worlds, and some scientists view them as scars from the collision of universes in the multiverse. Other outlandish theories suggest that aliens may darken galaxies in a void to harvest energy. As you can see, these mysterious voids challenge scientists and inspire the most imaginative theories. Of course, it's possible that our universe originated in a large void. The mere fact that we cannot disprove it bolsters such a theory. This leads us to the question of how matter was created. What exactly are singularities? We've already discussed the concept of nothingness, from which the universe supposedly emerged. If that was indeed the absolute starting point, how could we observe it, given that it was nothing and therefore undetectable? A singularity is a point where all forces are either so condensed that our usual measurements and values become meaningless, or where everything that exists is concentrated into a single point. This point is believed to have consisted of a fluctuation of possibilities existing in a state of complete equilibrium. A previously unknown event is said to have disturbed this equilibrium at some point, and creation began. From this tiny point, everything we know and see today came into existence. This means that the information for you, me, all life on Earth, every star, and every exoplanet was contained in this tiny speck of nothingness. The question of how an infinitesimally small dot of nothing could contain everything is one of science's greatest mysteries, and it's unclear whether we will ever be able to solve this puzzle. We find these enigmatic singularities in another place in the universe, at the centers of black holes. Black holes, which are believed to form when stars of a certain size explode, are located at the heart of almost every known galaxy. However, no one has ever been to the center of a black hole, and as we've discussed, we have very few means of observing the universe's absolute starting point, if it exists at all. Everything is based on calculations that made sense until the James Webb Telescope discovered something different from what our theories predicted. The Webb Telescope shows that the universe must be much older than we thought, or that its nature is vastly different from what our calculations suggested. Black holes are also among the greatest mysteries of cosmology. They are enormous, incredibly massive, and all the forces within them likely increase to infinity, making it nearly impossible for us to explore these infinite points using conventional methods. Currently, there is great hope in new supercomputers that, with their advanced intelligence, might be able to decode the secrets of the universe and reveal the true connections between its components. To this end, scientists are now leveraging the intelligence of quantum mechanics, which is believed to be the universal information storage of the observable universe. Meanwhile, other technologies are harnessing the storage capacity of water to generate extraordinary computing power. Click subscribe now to discover even more fascinating videos.